All right. In this video, we're going to practice our factoring. And I see a couple of different kinds of factoring coming. Would grouping work on number 13?
Yes.
Yes, grouping would work on number 13. Caitlin? Hi.
Hey.
If you look at these two right here, 30 divided by 5, what's that?
6.
That's 6. Now look at the next pair. I've got 18 and I've got 3. What's 18 divided by 3?
6.
That's also 6. Anytime you get the same number twice when you divide like that, that tells you that grouping is going to work. So I'm going to just use grouping to factor this problem. Okay, so when we do grouping, we'll do this pair and then we'll do this pair. So the GCF on the first pair is going to be 5x squared. What's that going to leave inside the parentheses? X and 6. All right, that means the other one is probably going to wind up being x plus 6 as well. And yes, we're going to pull out that 3, so I'll put like a plus 3 right here. Now the parentheses, the x plus 6 itself is now a GCF. So we'll pull out the GCF again, we'll pull out the x plus 6. That's going to leave behind 5x squared plus 3. So the only question is, does the 5x squared plus 3 factor any more? No. This is a sum, nothing I can do with that. Okay, so that's it. We factored completely. All right, I could have asked you to find the zeros as well, but I didn't. Okay, so number 14. Okay, we haven't looked at one of these in a while. Does anyone have any idea how to factor number 14? Go.
We add 0x squared.
I don't want to do it that way.
2 and then 3.
Yes, remember, this is the sum of two cubes. That has its own pattern. SOAP. This is that one where we do a binomial and then a trinomial. Okay, it's the sum of two cubes. Okay, for the binomial, we need to do the cube root of each one of these things. The cube root of 125. So remember, sometimes we use our calculator to make a little. All right, so you could make the list of the perfect cubes to help you on your calculator. You go to your table function, clear that out, and we could do x to the third power. If you do that and look at the table, okay, I'll scroll down a little bit. So these are all the cubes, 1, 8, 27, and so on. So we can use this to, at a glance, see what all the roots are. So as I look at the 125, and I look at my chart, where does 125 come from? Right, 125 comes from 5, so I'll use a 5 right here. And I'll just keep the same sign. Where does the 64 come from? 64 came from 4 to the third power. Okay, so I'll put 4 and then simply x. So I've got 5 plus 4x is my binomial. Now a trinomial has a beginning, a middle, and an end. The beginning and end come from squaring these two things. So if I take 5 and square it, that gives me 25. If I take 4x and square it, that's going to give me 16, and put plus 16 x squared. Don't forget to square that x. Now, the middle comes from multiplying these two together. So I'm going to get 20x. But you have to do the opposite sign. And to help us remember the sign, sometimes we use the acronym of SOAP, S-O-A-P, which stands for same, opposite, always positive. So compared to the original problem, the first sign is the same, the second sign is opposite, and the third sign is always positive. All right, so there it is. So that's the answer, number 14.
But you don't have to.
No, this trinomial will never be further factorable. It never will. It never will factor. Okay? So that's factoring. Might as well do number 15 and 16 along with these, because we're not going to do synthetic or anything like that for number 15 and 16. See how it's a trinomial? Okay? We can factor this like normal. So we can really just go like this. X to the fourth power will factor as x squared times x squared. 72, I'm betting that's going to be 8 times 9. All right? To make negative 17, they will both have to be negative. Okay? Now, the only question is, will either one of these factor more?
Yes.
Give me a thumbs up if either one of these will factor more. Give me a thumbs down if neither one will factor more. Okay, good job. I didn't fool anybody. Do they both factor more? No. What factors more? Only this one can factor more. So the x squared minus 8, I'm just going to keep that like it is. 8 is not a perfect square. But 9 is a perfect square. This is the difference of two squares. So I'm going to take the x squared minus 9 and break that down as x plus 3 times x minus 3. So this is now completely factored. All right, and I could find the zeros. Wait, it did say find all the zeros. Ha ha. Okay.
Factor and then find
It says factor and find all the zeros. So let's do the whole shebang. So these are the factors. Now we're going to go ahead and find all the zeros. Okay, obviously for these pink ones over here, the zeros are negative 3 and positive 3. How do I find the zeros from the blue one?
square root of 8.
That's right. All right, if I take this and set it equal to 0, adding 8 to both sides gives me x squared equals 8.
Could be
And then I need to take the square root of both sides. But I have to be very careful
plus or minus.
not to forget your plus or minus. Now this does simplify, okay? If I put square root of 8 in my calculator, this is going to give me 2 radical 2. Okay, so 2 radical 2. Yes, sir. So I have x is equal to plus or minus 2 radical 2. So you can either put plus or minus 2 radical 2 just like that, or you can write it separately and put 2 radical 2 and negative 2 radical 2. All right, so these are the answers to number 15. Okay. Similarly, number 16. X to the fourth power, again, is x squared times x squared. This is going to have to be 9 and 1. It will be positive 9 and negative 1 in order to make positive 8. Are either one of these factorable more?
Yes.
Which one?
X squared minus 1.
Only the x squared minus 1 can be factored. Does everybody understand that x squared plus 9 cannot be factored?
Because if it was negative.
If it was negative, we could. So we're going to keep the x squared plus 9 as is, and we're going to factor the x squared minus 1 as x plus 1, x minus 1. So these are the factors. And now the zeros. So here I will have negative 1 and positive 1 from those. And once again, if I set x squared plus 9 equal to 0, subtracting 9 from both sides gives me x squared equals negative 9. If I take the square root of both sides, I get plus or minus, and that's going to be 3i. Because we have a negative under the radical. So I'm going to put 3i and negative 3i.